Spectral acquisition is still the most basic method of analysis that we do. Under spectrum acquisition, whatever we're viewing on the SEM CRT or TEM CRT is what we're going to be analyzing. So it's that field of view. So if you use spot, line, or the overall view or a subset of that, that's what you're analyzing your data from. You have three basic operations that we do here. Preview is just that. It's an older technique that we've used for years. I'm going to clear off the original spectrum here simply by hitting X. So now we're doing a very rapid scan. So the way this thing is set up, remember, any place we see a down arrow key brings a menu. We're currently telling the system to start a new spectral acquisition every 400 milliseconds. So what this allows me to do is I can scan the sample. So if I'm looking for a particular element, I can go to the periodic table, and let's say I was looking for titanium within this sample. Alright, so there's my titanium marker. So now I can move it about, and when I see an area of interest that maybe contains titanium, like there, now I found the area of interest, I can then do a more extended analysis. So I'm going to stop preview simply by clicking on it. Under Acquire, they give you a wide variety of tools to work with. Automatic, you have three basic modes: fast, precise, exhaustive. Basically what you're doing is you're fixing how many counts you want in the overall spectrum. Fast yields about 100,000, precise is 3, and exhaustive is 1,000,000 counts total within the spectrum. Manual is another option, which means keep collecting until I tell you to stop. You can also do real time and live time, so full dead time correction or just clock time. Or you can specify your own region. So let's say you were analyzing samples that all had fixed amount of iron, but you were looking for variations and everything else. You could set for 50,000 counts within the iron peak, so that you'll always know you're getting the same amount of data within that region, and then compare differences. The automatic quantification is a tool that will allow you to do auto ID with quant if you wish, or just quant by itself if you want to do a preset list while you're acquiring or post acquisition. The cyclic acquisition is a nice way for checking for contamination issues. So with that, you can start an analysis where you tell it to count for so long and then pause the spectrum and then continue on with the analysis. You also have the autosave feature in here, so we can elect to save each spectrum automatically to projects, put them into the report, or save them to a discrete folder on disk. And again, you have your automatic numbering. So if you turn that on, first spectrum will be 1, second 2, using the prefix name that you put up in sample. Alright, so with that all set up right now, I'm ready to start doing my analysis. So when I press Acquire now, that starts the acquisition. I'm currently in manual mode. Over here I can pick up any of the axes, so I can slew, move them up and down, maintaining the gain that I've set. A is the automatic vertical and horizontal scale. Click that and adjust the system to its maximum height. Additional controls here is under options is you can elect to have the log scale, square root, which is a nice alternative, dynamic scaling for comparing multiple spectrum. If you go off axis or you're subtracting one spectrum from another, you can actually show negative counts if you need to. Grid, bar graphic, which means you're switching from smooth to non-smooth. Legend, which is the name with the color code up in the upper right hand corner. And then cursor information, how much information you want to know about the cursor and place it. Also, you can have the system have an XY cursor, so if you like quickly to look at heights and get estimates very quickly manually, you can do that as well. So right now, I'm going to call up the periodic table tool, which I click here. And this is the main tool we use for working for identification and for working with regions of interest. I'm going to hit clear all right now to clear the list. And now I want to have the system automatically redo the auto ID. Since I left the system in continuous, it did that for me as soon as I cleared the list. So that's the current element. Now, with auto ID, you can set all the elements you want to compare. So at this point, anything in blue, we're telling it those are possible elements for you to look at. Anything in gray, we're saying don't bother with those, I never see them. You can change this at any time simply by clicking on it. So for instance, if you know you're never going to see hafnium in your sample, clicking on it turns it to gray. It's not going to bother checking for that. I can also set a minimum concentration. So right now I'm telling the system any element whose concentration is less than 0.5%, don't bother with it. So in other words, I'm telling it, you do the majors, I'll do the minors. So with that set up now, that's my current auto ID. I can then go through here and utilize any of the other tools. So for instance, I can simply click on any KLM marker at any time and it brings it up onto the display. So there's aluminum. If I wish, I can then move aluminum up and down an atomic number following Moseley's law. So it's a nice way for checking for adjacent elements. Okay. You can also use the computer assist ID. So if you're not sure of what element to select from, you can go to a region and either simply place the cursor in the center of that, or if you want a larger sampling, press the right mouse button and drag it and you'll get a larger region of choices. So these are the choices within that region. And as you see, the two main lines are potassium, which makes perfect sense, and indium. Now, if that were indium, I'm missing a lot of lines here, and I'm also off center. So potassium makes the most sense. So with that, I've identified potassium in here. I also remember seeing I had an aluminum peak over here, so I'm going to add that to the list. And now I can simply click on any additional elements that I wish to identify on the display at any time. So all my methods are, I can use auto ID, I can manually click on any KLM marker at any time, put the marker up on the display, I can use the computer assist, I can pick up any marker and move it up and down an atomic number following Moseley's law. Now the other capability that is built in here is what we call dynamic lines. Under normal circumstances, if I was to scale my titanium marker to the peak, we see that I can scale the titanium K alpha line to the top of the peak, but the K beta line is not proportional. And the reason for that is because we're not taking into account the background. When I turn dynamic on, it automatically compensates for the background, so the markers now mean something. So now I can see that I'm counting for full height of the peak on my iron, my calcium, my titanium, so I can be pretty well sure that the only thing this peak is due to is iron, titanium, etc. So it's a quick visual check, and it's a nice way of presenting the data. In addition to that, you can turn off the lines and just leave the markers, and you can turn off the dynamic scaling, and if you want the markers up like so, which is sometimes nice when you have multiple spectrum and comparing them. If you want more details in your markers, you can either double click or press the right mouse button, and that brings up the information about your KLM markers. So in here, this allows you to specify the background color. It allows you to specify how detailed you want the markers. So I'm going to take it off automatic mode. In automatic mode, we only label the alpha peak, but everything else, all the other markers are there. So you see we're color coded, so all these yellow lines are part of titanium, but only the alpha line is marked. If I want the K beta one, I can click on it, and now I've got the K alpha one and the K beta one. If I want the full label there, I can say show lines. And now it's showing me this is the titanium K alpha 1, this is the titanium K beta 1. And if I want to do that to all the markers, I can just hit all now, and now they all get fully labeled. But only the alpha line because I didn't turn the beta lines on. You can see why we don't always put up all the KLM markers, because it'll get a bit crowded on the display. But it's your option. You can set this up any way you want, either right now as you're doing the analysis, or if you want this permanent, there's a way of doing that too. And we'll show you that in a later movie. So with that, right now I'm going to just switch back to the normal, and I'm perfectly satisfied with that setup. So now if I want to take this data and put this into a report, I can come over here on the in and out control, and I could say add it to projects, add it to the report, open up previously collected spectrum, save it, or print it. We're going to just simply say add to report. And now let's put it on a single page all by itself. And as I add more data, it'll keep appending to the report. So if we go to another area, start collecting a new spectrum here. Alright, so I'm going to clear all again. And again, I do have auto ID on, so it'll update, and I'll pick up the trace peaks. So now I want to put this into my report. I can simply say add to report. And now we'll see that'll fill the bottom half of here. So as I keep adding, I can always append the report, and the system will keep adding pages as we go along from one report to another. Other manipulations one can do with the spectral display. If I want to do a very, very specific axis, I can right mouse click on any of the axes and specify the exact X range I want. So if I wanted to set up my display to be exactly 0.2 to 5.7, I can have that set. And if I want the vertical scale to be 200 counts per second per EV, which is the mode I'm in, there it is. So we can go through here and set this up. So if you want to do comparison and have exactly the same scale on each of the spectrum, this is a way of handling it. Remember, your other display controls are located under objects. So you can switch again between the various typical displays such as log and square root, turning the grid bar on or off. You can also use the zoom function. With the zoom function, you can then just simply highlight this box about the area you want to zoom up on. And again, automatic vertical scale A will automatically put you back to the other functions. Now there's two other functions built into here. Spectral math, which allows you to add, subtract, and divide spectrum to one another, and also the match program, which allows you to compare any set of data to previous data that you've collected. It's a nice search tool. These will be handled in a later movie. So spectrum acquisition is your main control. From this, you may want to go into one of the other controls, such as object mode if you're seeing a lot of variations and want to document it with images, line profile to show subtle differences, or the ultimate is to do X-ray mapping. And these will each be handled by a separate movie.